4, 3, 2, 1.
The dawn of a new era is here. The era of all flash. The end of compromise, inefficiency, and complexity. And the beginning of the age of the effortless, the exceptional, the extraordinary. In the new age of data storage, data will be bigger, more varied, more accessible. Expand your horizons and join us on this exploration of what's possible. See how this changes everything.
Hi, I'm John Colgrove. I'm the founder and chief visionary officer here at Pure Storage. I'm really excited to talk to you about our latest step forward in replacing all of the disk out there on planet Earth. So, if you look back at the history, disks were the dominant technology from 1970 until today in storage. And they really, over the first 40 years of that or so, had some phenomenal exponential growth. Every year, getting way cheaper, way more efficient, way denser. It was just an astounding run. But I'm sure if I asked anyone, what will the dominant storage technology be in 1,000 years? Nobody would say disk. In 100 years, nobody would say disk. We're at the point now where it's time to replace disk with all flash. And at Pure, we started that journey 14 years ago when we began the company. We looked at the highest performance disk and said it's no longer meeting the needs in the marketplace, and we could build an all-flash array. The flash was a lot more expensive, but here performance mattered. And we saw this exponential curve in flash that was much, much faster than the curve going on in disk, because disk was flattening out. It was getting harder to improve the disk all the time. And so we looked ahead and we said, okay, it's all going to be flash, and it's going to happen sooner than anybody thinks. And we started that journey. So 10 years ago, we'd ship a product with 256 gigabyte or 512 gigabyte SSDs. Today, we sell petabytes of flash array in a single flash array. And we sell direct flash modules that are 50 terabytes. Now, along the way, we also created the FlashBlade product, because as good as flash array is, it is a scale-up architecture, and there's a limit to how big you can get. There's a limit to how efficient you can get. And so we needed the scale-out architecture to go beyond that. And so with the two architectures, we can go from the smallest use cases to the largest use cases, tremendous scale and great efficiency on the flash. Now, what's happened over the years, 15K RPM disks disappeared in favor of all flash. All flash moved on to attack hybrid arrays and 10K RPM spindles. But there's still this gigantic amount of nearline disks, 7,200 RPM disk spindles out there, thousands of exabytes of it, and that's remained out of reach until now. As flash has continued to improve, as the economics per bit get better, as the density gets better, as the power efficiency gets better, we get to the point where we can now go toe-to-toe with 100% disk arrays. An all-flash array, a disk array, roughly speaking about the same cost to buy them, and the flash array is just so much better as you go forward in time. Disk, as you know, as it ages, the failure rates go up. Our direct flash modules, and this is something where from the beginning we've focused on all flash. By focusing on all flash, we really get the most out of it. We get performance that's good from just a very few flash drives. We get more consistent performance. We get better lifetime, and we get better reliability. One of the ways we get better reliability is our software is just better because it's simpler. Our direct flash modules just have to deal with our storage. They don't have to cover every use case out there. That simpler firmware means fewer bugs. And, you know, all software has bugs, but whenever we find bugs in that, we're shipping fixes for it, just like we ship software updates all the time. So our direct flash modules actually, they start out 3 or 5 times as reliable as an SSD, and they get more reliable as the years go by. So you come back to all flash and you say, well, okay, you've got these direct flash modules, you've got this really scalable architecture. How's that going to replace my disk? Well, you have to recognize that disk over the last 10 years, maybe it's improved 4x. Today I buy a 20 terabyte drive. 10 years ago, I'd buy sort of a 6 or an 8 terabyte drive. So 10 years ago, we'd ship a product with 256 gigabyte or 512 gigabyte SSDs. Today, we ship a product with 50 terabyte direct flash modules. 512 10 years ago, 100 times improvement over that last decade. And the way flash grows, we already see from the flash vendors' roadmaps 75, 150, 300 terabyte direct flash modules. By the end of this decade, we'll be able to put a petabyte into a flash module that's the same size as the 512 gig we sold you 10 years ago. And it's going to use the same amount of power. And when you think about it, you look at all the disks out there, thousands of exabytes, so many tons of e-waste, but so much power used. Data centers, people talk about they use maybe 2% of the world's power, and storage is, say, a quarter of that. It's just insane that we waste that much power on spinning rust, and that's what the disks are. So we started all those years ago looking to change the whole market. We're now starting on the last stage of that journey, right? We went after the high performance. Now we're going after all of the nearline storage, all the video use cases. You go to an airport, you look in a factory, they have all this video to monitor the quality, to monitor what's going on. All of that goes to disk today. Why does it go to disk? You stream the data on. It's a little bit annoying when you want to use it. The access, isn't that fast. But disk was the only thing economical enough to store it all. Well, now that can be all flash. Think of a media company that has all the footage they've ever done, or medical imaging, right? If I go get an X-ray or a CT scan or any other test, they want to keep it for my entire life, plus maybe some years after. And in order to store that, you're now thinking about storing data for 10, 20, 50 years. That's where our evergreen architecture comes in. Our products from the beginning have been designed to be evergreen. You upgrade them in place. As new technology comes along, you do plug-and-play swaps to newer, better hardware, push-button upgrades to newer, better software, and it just gets better and better and better over time. So as you've heard, we've launched the FlashBlade E, and it's our most exciting new product in this journey to eliminate disk from the face of planet Earth and replace it all with flash. You've heard about FlashBlade E? Well, guess what? It's going to ship now, and you're going to buy 48 terabyte direct flash modules in it, and you're going to say, hey, I'm buying my storage for this year, but I'm going to need more next year and more the year after. And at some point, you're going to look and say, hey, gee, Pure's now shipping 6 times the size, like 300 terabyte flash modules. So I want to go and I want to swap out my old flash modules for much newer, denser ones. I'll keep my power usage the same. I'll shrink my footprint in the data center, and I'm just off to the races. You don't have to migrate the data. It's non-disruptive. And so, it's really a long-term take at how you buy the storage today for even those, lowest performance, most cost-effective use cases, and it just gets better and better and better over time. That's been a hallmark of Pure from the beginning, and I think it's one of the key things that helps drive this. I referred to it at the beginning. The acquisition cost is about the same. It's a lot better to operate the all-flash, but where the real benefit comes in is in this long-term TCO. When you think about buying massive amounts of data, whether it's to power high-performance databases, medium performance, or medium performance density, I should say, workloads like machine learning that are very high performance in aggregate, or archival long-term repositories. You buy it, it gets better and better over time. The TCO benefit of an all-flash evergreen architecture is gigantic. And so I'm really excited about the FlashBlade E. It's the start of the last part of our journey on changing the entire storage marketplace from disk to flash. And we're going to do that. And now I'd like to invite you to hear a lot more about FlashBlade E and what we're going to do with it in the future. Thank you.